Hello class, this is a video tutorial on comparing fractions with different denominators. In this one we're asked to convert the pair of fractions to equivalent fractions with the same denominator. So here we have a pair of fractions and we want to change both of them so that they have the same denominator. But remember, it has to be equivalent. We can't just change it so that they're both 8. It has to be equivalent. Let's focus in on this first question here. In order to make these the same denominator, we first have to figure out the lowest common multiple between 5 and 8. So let's list out the multiples of 5 and the multiples of 8. In case we've forgotten, multiples are just the times table. So here we have 5, 10, 15, 20, 25. Let's stop here for now. Let's see if we can figure out for 8. We have 8, 16, 24, 32, 40. I believe it's going to be 40 because it ends in a 0. But let's keep going. 25, 30, 35, and 40. So that is the lowest common multiple between both 5 and 8. And as such, what we do is underneath each of them, I'm just going to draw a new fraction where it's over 40. For 5 to become 40, so I'm going to draw a quick line going all the way down here. For 5 to become 40, what has it multiplied by? Well, 5 times 8 equals 40, which means we have to multiply this numerator also by 8. So 4 times 8 is 32. For 8 to become 40, we need that to multiply that by 5. Which means we also have to multiply the numerator by 5. So 7 times 5 is 35. And from here we can quickly see which one's larger or not, but we're not asked to do that. Let's do another one. Let's look at the multiples of 12 and 3. I'm actually going to start with a smaller one first, hoping that it can become 12. So multiples of 3. We have 3, 6, 9, 12, and 12 times 1 is already 12. So our lowest common multiple is going to be 12. So 12 is actually going to become 12 again. So this actually doesn't change. So for 5, so 5 over 12 still stays as 5 over 12. But 5 over 3 has now become 12. So 3 to become 12 is multiplied by 4. So 3 times 4 is 12. So 5 must also be multiplied by 4, which gives me 20. Now it gets a little trickier once we have mixed fractions. What we actually do first is we have to convert both of them into an improper fraction. So underneath this, I'll do it in black so we can see. 3, so in case you've forgotten how to do it, it's actually 3 times 1 and then plus 1. So how we do it is 3 times 1 is 3. 3 times 1 is 3. 3 times 3 plus 1 is 4. So this becomes 4 over 3. And the process is the same for this. 5 times 1 is 5. 5 plus 2 is 7. So we get 7 over 5. And once again, at this point, we want to change both the denominators so that they are equivalent. So the multiples of 3, 6, 9, 12, 15. I'm pretty sure it's going to be 15. Multiples of 5, 10, 15. So both these fractions will become something over 15. So for 3 to become 15, we need to times by 5. So this will become 4 times 5 is 20. For 5 to become 15, we need to multiply by 3. So 5 times 3 is 15, which means 7 times 3 is 21. Same process again. 5 times 1 is 5. 5 plus 4 is 9 over 5. 2 times 2 is 4. 4 plus 1 is 5 over the same denominator. Let's find the lowest common multiple between 5 and 2. So 5, 10, 15. We'll just do the first 3. Multiples of 2 are 2, 4, 6, 8, 10. There is our lowest common multiple. So 5 will become 10. So for 5 to become 10, we need to multiply by 2. So 9 times 2 gives me 18. For 2 to become 10, it has multiplied by 5. So 5 times 5 is 25. So this is converting fractions to equivalent fractions with the same denominator. Okay. In the next part of this video, we're going to look at how to use this skill to arrange numbers into ascending and descending order. Okay, so I'm going to quickly pause the video here and we'll continue right after this.